let's get started. I think this is problem number 2, or something like it. You'll have variations, of problems like this where the numbers, could possibly be changed. All right, so this is a triple integral, but as usual, we'll treat it as an iterated integral and do the integral on the inside first. So what do we have? We have the integral from 0 to ln of x e to the negative y dy. That's the inside integral, okay? Y goes first. We can have permutation of dy dx dz, which gives us 6 different possibilities. Well, here's one of them. All right, so to do this integral, you want to remind you of a little shortcut, right? So the shortcut is, suppose we had e to the 5y, right? Then you would do a u substitution. You would find, that you'd let u be equal to 5y, and then du would be 5 dy, and you have to move the 5 to the other side. So you'd end up with the integral of 1 over 5 e to the u. And, after doing that, you're going to get e to the u, and the 1 over 5, the fraction is going to remain. So, without doing u substitution, then you can just write this as 1/5 e to the 5y. Of course, we have limits on this integral, but, if you didn't, if this was an indefinite integral, you'd put plus c. So I want to contrast this with derivatives, right? Because if you were taking the derivative with respect to y of e to the 5y, it'd be e to the 5y times 5, all right? But with integrals, it's, divided by. All right, so how does that apply over here? Let me pick up my eraser. My cat was playing with it. So it applies over here because, the coefficient of y is -1, right? So the -1 comes out as a fraction, but of course, if you divide by -1, it's the same as multiplying by -1. So the integral, evaluates to negative x e to the negative y between 0 and ln of x. Okay, so using the fundamental theorem, we have negative x e to the negative ln of x minus a minus x e to the 0. E to the 0 is 1. All right, so let's evaluate this e to the negative ln of x. You will probably recall the property of the natural log, that if you have r to the ln of x, that can be written as ln of x to the power r. Okay, so the r can come out in front as a coefficient of ln of x. We also have another property that could be useful here. If we have the natural log of 1 over x, that's equal to negative the natural log of x. Okay? That's because, if you have ln of a over b, it's equal to ln of a minus ln of b. All right? So, take your pick, whether we have the negative and we put that as x to the -1, right? And let's just do that, right? So the negative comes and we have x to the -1. So if we have x to the -1, right? So we have e ln x to the -1, then we can take advantage of the fact that, e and ln are inverses of one another, which, cancel. And this gives us negative x times 1 over x plus x, right? Of course, these now cancel in turn, and you just get -1. So this integral evaluates to x minus 1, all right? Okay, and that's not visible. So over up here we go, x minus 1. That's what the inside integral evaluates to. All right. Okay, so let's take that answer and then go back to the integral. All right. So we'll erase all this stuff. Okay, now the integral becomes a little bit less daunting, right? Because now we have I is equal to a double integral. Of course, that will be treated as an iterated integral also. Right, and the integrand inside is just x minus 1, and then we have dx, and finally dz. All right. So the inside integral in this case here is an x integral, and let's go ahead and do that one. All right. So I'll just create a little scrap paper here. So we have the integral from 0 to 2z of x minus 1 dx. It's a pretty, straightforward little integral. 1/2 x squared minus x between 0 and 2z. All right. So if we plug in 2z, we have 2z squared, which is 4z squared, 4 over 2. So we have 2z squared, 1z, 2z's, right? And then we have minus 2z. Okay. All right. So the integral, the inside integral evaluates to 2z squared minus 2z. Perfect. All right. So let's go back to the integral now. All right. So what's left of it? Well, now all that's left is the integral between 2 and 3, all right, of 2z squared minus 2z dz. Okay. All right. So let's do that. It's another easy integral. We add 1 to the exponent and divide by the new exponent, right? When we're integrating something to a power, the nth power is the n plus 1 power divided by n plus 1, of course, if n is not equal to -1, right? We stay away from that. Let's see what we have over here. Again, the invisible power being 1, we add 1 to the power divided by the new power, and we get 2 times z squared over 2, so we just get z squared. And then we go between 2 and 3 and evaluate this, right? So let's see what we have. So we plug in a 3. Well, we have 3 cubed, that's 27, but 27 over 3 is 9. 2 times 9 is 18, so we get 18. And if we plug a 3 in here, we get minus 9. Okay, that's cool. So then minus all this stuff with a 2 plugged in. See, I put parentheses around it to make sure, that I'm going to distribute the minus sign. All right, so what do we have? If z is equal to 2, we have 2 cubed, which is 8. So this gives us 16. I don't know why I wrote 18. 16 over 3. And then I plug a 2 in here, and we have 4, right? So what do we have? 18 minus 9 is 9. Plus 4 is 13. Minus 16 over 3, right? So we have 13, right? This is all equal to 13, right? Minus 16 over 3. Well, 13 is 39 thirds, right? So we have 39 thirds minus 16 thirds, and that's going to be 23 thirds. And that is the value of the integral. Okay? 23 over 3. Good, right? I'll write it up here. 23 over 3. The next integral, this is 3. And, again, you're going to have something like it. They give you a triple integral, and they just say, okay, here's some region Q, where Q is the inside of this cheese log, if you want to think of it that way. Okay. The interior, right? The exterior and then everything inside. So they just gave us this diagram, and they were supposed to figure out, what order we're going to do the integration in. Are we going to do it y first, or x first, or z first? So it may at first look like, you have, you can look at the world, the way you normally do, with the XY plane being the floor, and, or the ground, and then this being the sky. Well, you could actually do it that way, right? But then, it'd be a little bit more complicated, because you see, if you look at this cheese log, you have a top and a bottom. Well, the bottom would be 0, but you see, then we have, 2 tops. So we'd have to, we'd have to be careful and write the integral, probably 2 integrals, at least 2 integrals, to do it this way. But if we look at it, where the ground is, the XZ plane, right? A little crazy though, right? So, if these are the trees coming up, Here's the trees, coming up from the ground. And then this is the sky here. See, there's the sun, right? Then we can look at it as one roof, which would be, the sort of slice of the cheese log. That would be the top, the roof. And then the floor would just be the XZ plane. In fact, the floor would be y equals 0. Now, when they drew this, it's a little bit confusing, right? Because, they give you a y y is a function of x and z. Of course, x is missing from this, but, they give you a function for this, and this is the top, and that's very good. Y is a function of x and z, but then they give you this function z here. Well, that z equals 1 minus x squared. That just refers to this parabola that, hits 1 in the front and, unseen -1 in the back. The floor of this object really is y equals 0. Let's, put that away for a little bit. You see the floor of this object is y equals 0. So we have a roof and a floor, okay? So that's going to, result in a y integral, y going first, all right? And then the patch of grass would be this little, parabolic region in the XZ plane, which we'll look at, okay? All right, so, I think I'll erase the trees, right? We have the sky, this is top and this is bottom, right? Top is y equals that stuff, and bottom y equals 0. So let's rewrite this integral, all right? So we have I equals, can I write over that far? Yeah. So I equals integral, right? Y goes from a low of 0 to an upper of 2 minus z, right? That's a function of x and z, even though the coefficient of x is 0 at the moment, right? So that's why, y, can be written as the roof, right? It goes over the xz plane, right? And then the floor is y equals 0. All right, well, the integrand here is 9x, right? What's that about? Well, remember I said when you're doing an integral, triple integral, you can think of the integrand, I like to think of the integrand as a temperature function, right? Because, a height function, of a function of 3 variables, the graph would have to be in 4-dimensional space. So, that's not really convenient for sketching purposes. But you see, the integral takes place inside of this cheese log. But 9x is going to refer to the temperature inside at every point, in that cheese log. All right, so now we have the roof and the floor. Fine, that's dy, right? Now, for the x and the z integral, we have to look at the patch of grass. And as I noted, the patch of grass is going to be in the xz plane, right? Let me just sort of abstract that. Instead of writing as perpendicular axes, I'll, just, write it like this over here. How about we write it so it looks like, the original thing, right? So the graph of, the floor or the patch of grass is going to be that parabolic region, right? So here's the grass, right? Over which, the height occurs. And so, we could write that as a whatever type you want. I guess we could call it a type 1 because z would be the dependent variable and x would be the independent variable, which is going to go between -1 and 1. And then z would be equal to 1 minus x squared, right? And this is the z-axis and this is the x-axis, okay? Drawn, like this, we would have z is equal to 1 minus x squared, where x goes from -1 to 1. And then this is a patch of grass, all right? Looking down on it. And this is the x-axis, and this is the z-axis. All right, so, in light of that, then, we could write, dz next, where z goes between 0 and 1 minus x squared. And then finally, dx goes from -1 to 1. So from this diagram, and the given integrand, we've built our integral, okay? All right, so let's have at it. Okay, once again, we'll, carry out, we're going to evaluate the integral as an iterated integral. And we have an integral with respect to y. All right, so here's some scrap paper. Goes 0 to 2 minus z, okay, of 9x dy, right? 9x being a constant, both 9 and x being constants. We get 9xy between 0 and 2 minus z. All right? Okay, so plugging into 2 minus z, what do we get? 9x and then 2 minus z minus 9x times 0, which is 0, of course. So let's see what we get. We get 18x, 18x minus 9xz. And that was the inside integral, okay? All right. Okay, so let's remember that, 18x minus 9xz. And, reduce the number of integrals we have, making it less scary, right? So we have 0 to 1 minus x squared, and then we had 18x minus 9xz, and that's a dz integral, and then the outside integral will be an x integral. Oh, I don't need two integrals. Well, yes, I do. Yeah, I need two integrals. And then we're going to extract this one on scrap paper, okay? Okay, so the next integral, the next iterated integral is, 18x minus 9xz, and that's the z integral. So let's do that one on scrap paper, okay? So we have 0 to 1 minus x squared of 18x and minus 9xz integral, partial integral with respect to z. So we have 18xz minus 9 over 2 xz squared, and that's between 0 and 1 minus x squared. All right? Okay, so to make this a little bit easier, I'm just going to erase this because all we have left is an x integral after that. All right, so make this a little easier. I'll factor out a 9, an x, and a z, right? So 9, an x, and a z, and then let's see what's left over. 2 is left over here, and then we have 1/2. The x is gone, one of the z's is gone. Yes, makes this a little bit easier. 1 minus x squared. So let z be 1 minus x squared. I have 9x times 1 minus x squared. And then inside here, I have 2 minus 1/2 times the quantity 1 minus x squared. All right? All right, so let's see what we have here. So 2 minus 1/2, that's 3/2, minus a minus, a half x squared. So it's plus x squared. So, so let's see, we have 9x, 1 minus x squared, and then we have 3/2, okay? And then plus 1/2 x squared, okay? Cool. Let's see. Let's factor out a half, right? So that'll just make it a little bit easier to do the foiling. Okay. So if I do that, I have 9 over 2 x, 1 minus x squared, and then inside of this parentheses, I just have 3 plus x squared. Okay, cool. So 9 halves x, and then we FOIL this. We get 3, 3, okay, plus x squared, minus 3x squared, minus x to the fourth. Okay. All right, so that means inside the parentheses here, we have x squared minus 3x squared. That's negative 2x squared. So we have 9 halves x, and then we have 3 minus 2x squared, and then minus x to the fourth. Okay? Distributing the x, and we'll leave the 9x out. And then what did we have? We had the integral, so the remainder of this is the integral from -1 to 1. Like I said, I'll take the 9 halves and put it outside and distribute that x. So I have, in power descending form, we have negative x to the fifth, and then we have negative 2x cubed, and then positive 3x, right? Dx. Okay. Aha. Okay. Well, there's something very nice about this integral. Very nice indeed. This integral consists of all odd powers, which makes it an odd function. Okay. And if we take the integral of an odd function between negative some number and positive that same number, that whole integral is just equal to 0. All right? And I'll tell you why. Because you see, you know how even functions are symmetric about the y-axis, an odd function is symmetric about the origin. And what that means is we have a function that looks like, sine. That's a good example, right? So if I'm integrating sine between negative pi and positive pi, right, look what happens. The area on the left side cancels the area on the right side. And that's true of every odd function, right? Because it's sort of, rotated by 180 degrees. That's what we mean by symmetric about the origin, right? So the integral is 0, and this integral is 0 here. Fantastic. Well, it was a lot of work for 0, but it's 0. I think we could have figured that out, actually, because let's go back to the original problem. It's 9, the triple integral of 9x. So that's, think of that as, like I said before, some sort of a temperature function. And let's remember what we were integrating, right? What was the object that we were looking at? We were looking at this cheese wedge, right? So it came down like that. Okay, and then there was a sort of a slice, taken out of it, right, looking like that. Okay, and then you wouldn't see this because the y-axis would poke out like that, and then this is the x-axis and this is the z-axis, so you wouldn't see all this stuff inside here, right? You would just see this. Okay, all right. So let's look at this object, right? And here's the y-axis. It's symmetric, right? This has symmetry. In other words, it's the same sort of object on the negative x-axis as it is in the positive x-axis, right? See this line here? This is directly over the y-axis, and so if you split this thing in half, cut it like that, it's exactly the same on either side, right? So if you have a temperature function of this object, which is symmetric about the y-axis, okay, I'm not talking about odd or even, at this point, but, we have the same object, if we were to divide this along a vertical slice of, that's parallel to the z-axis, right? The vertical slice, which is the YZ plane, right? So it divides that in two. Well, the temperature on one side is exactly the opposite of the temperature on the other side. For example, the temperature right here. What is this point? Well, I guess Y is like, what was this? This was like 4 minus Z or something like that. Yeah, so when Z is 0, this is equal to 4. Well, that's the Y coordinate is 4. But we don't care about that, right? What we care about is the X coordinate. The X coordinate is 1, right? The Y coordinate is 4, and the Z coordinate is 0. But this point over here, the X coordinate is -1, the Y coordinate is 4 again, and the Z coordinate is 0 again. But the temperature being 9x, the temperature is 9 degrees over here, but -9 over there. So at every point, you're going to have an opposite temperature. So, well, the triple integral of this is 0, and the average temperature is 0. And that makes perfect sense because, of the symmetry. Okay, good.